Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And today we are analyzing this question. It says, consider the arrangement below. This is the arrangement we're having. We're having a mass M sitting on the horizontal platform attached to a string which goes over the pulley and at the end attached to 3 kilogram mass. And they say the blocks are stationary. Then it says calculate the tension in the string. So when you reach this situation, how do you go about that? Okay. When you look at M is too much unknown. You don't know the friction force, so we don't know the coefficient of friction. But when you look at the hanging mass, let us look at his free body diagram. So here we have our string creating the tension, and you have Fg, or gravitational force. Okay, that is what we are having, and we are saying the blocks are stationary. That one is called equilibrium, static equilibrium. So if the blocks are at equilibrium, how do you go about this? There are two approaches. One, whenever equilibrium is existing, the sum of forces in one direction are equal to sum of forces in the opposite direction. In other words, we can say that T is equal to Fg because of this word stationary. Or you can use Newton's second law to come up to the C equation. What does it say? You can say F net is equal to ma, and remember stationary means acceleration is 0, so it's going to be m times 0, which is 0. So F net is 0. Another circumstance, what do? You are going to say you put F net in terms of the forces involved. You are going to say F net is equal to Fg cos 0. I'm taking downwards to be positive, plus T cos 180 degrees. From here, we can bring our 0 and put it here because that's the F net, and we say Fg minus T. When you rearrange this one, it goes back to the same equation above. What is the equation? Which says T is equal to Fg. So the choice is yours here. So if this is true, what is true? That T is equal to Fg. How do we proceed from here? We are going to say this one is equal to mg. And do we know m? Yes, we know it. M is 3. Do we know g? Yes, we know it. It's 9.8. What you get out of here is going to be our t. Let's get it. So that is what we get. We get our tension as 29.4 newtons. Okay, let's look at the next question. Then comes the next question, 7.12. It says, calculate the minimum value of m that is required to prevent the blocks from moving. And they give you mu s on m is 0.3. How do you go about that? Okay, like what is 2? The best approach is to have the free body diagram of M. So when you look at M, it is anticipated that we have our force here, which is tension caused by the string. And because we have coefficient of friction, we have friction force this side. But there is one concept of friction force which you need to know, that friction force before the body starts to move is equal to the applied force. The minimum force required to make the body move is equal to maximum static friction force. So in that aspect, that's the minimum force required to make the body just to start moving. That force is equal to maximum static friction force. When that force is exceeded, the block will start moving and we'll stop talking about static friction force and we start talking about kinetic friction force. So in this aspect, what are we having here? We have to remember that T is known. We got it here. It is 29.4 newtons. And we have also to remember that the body is stationary. Stationary means that the sum of force it means equilibrium, implying that the sum of forces in one direction are equal to the sum of forces in opposite direction. So what are we having here? We are having the scenario. We are saying T is equal to F max static or maximum static friction force. But this one, we know its expression. We know the expression of maximum static friction force, which is equal to mu s F n. Now you have to remember that M is lying horizontally. In that case, we are going to say Fn is equal to mg because of that horizontal arrangement. So what are we going to have here? We are going to say T. Our T is 29.40 is equal to mu s mg, and mu s is given. Mu s is 0.3 and m is wanted, and g is 9.8. So altogether, this is what we are having. We are having 29.40 equals to 0.3 times m times 9.8. That's what we are having. Now, when you look at this expression, the only unknown is m, which we can get. Let us now rearrange and make m the subject. So m is going to be equal to 29.40 over 0.3 times 9.8. Okay, what do we get from there? Let us see. So we get 10 kg. So 10 kg is the minimum magnitude of the mass which will stop the body, the system from moving, which means that if you put a bigger one, it will not move if you increase in size. But if you put any mass below 10, the system will accelerate downwards, or M will move to the right. Okay, that's the thing, and we thank you for your time. The channel is PSSB Don't forget to subscribe. It's me, Richard, here. See you next time. Bye bye.